Hi everyone, in this video we're going to calculate which reactant is the limiting reactant. The limiting reactant is the one that runs out first in the chemical reaction and causes the reaction to stop. The other reactant that is left over is called the reactant in excess. So let me show you what I mean by looking at a practical situation. In this example, I have some hydrochloric acid in a flask and some pieces of magnesium. So I'm going to add half a spatula of the magnesium to the acid, and we can see straight away that there's a lot of fizzing, it's generating hydrogen gas, and it will also be generating heat because it's an exothermic reaction. And we'll come back to that in a few minutes. We can see that the reaction has now stopped, and the reason it stopped is we've run out of magnesium. So the magnesium is the limiting reactant. We've still got some acid left, so that's called the reactant in excess. And to prove there's still some acid in that solution, if I was to add some more magnesium, the reaction would continue. So it just shows that it was the fact that the magnesium had run out that caused the reaction to stop. Let's take a look at how you work out which is the limiting reactant and which is the reactant in excess. In this example, the question tells us we've got 20 grams of CaCO3 reacting with 100 grams of HCl, and we need to work out which is the limiting reactant and which is in excess. And you will always be given the symbol equation on your exam question. So with these, all we do is work out the number of moles of each reactant using either moles equals mass over AR if we're dealing with atoms, or moles equals mass over MR for a molecule. So first we'd work out the moles of CaCO3 by doing mass over MR. The MR of CaCO3 is 40 plus for calcium, plus 12 for carbon, and 16 times 3 for each of the 3 oxygens, and that comes to 100. So we put that into the equation above. The question tells us we've got 20 grams of CaCO3, so 20 over 100 is 0.2 moles. And at this point, it's a good idea to write it under the CaCO3 in the equation. We do exactly the same for HCl. Moles of HCl equals mass over MR. The MR of HCl is 1 for the hydrogen plus 35.5 for chlorine. So the total MR is 36.5. And in the question it tells us we've got 100 grams of it. So the moles is 100 over 36.5, which is 2.74 moles. And once again, we annotate the equation with that number. So we can see from the balancing numbers that we'd have 1 molecule of CaCO3 reacts with 2 molecules of HCl. So if we had 0.2 moles of CaCO3, really we would want 0.4 moles of HCl, but we've got more than that. So the HCl is in excess, that would be left over, and the CaCO3 is the limiting reactant, which when it runs out would cause the reaction to stop. Have a go at question 1 for yourself, and then pause the video and check back in to see if you've got it right. So first of all, work out the moles of Cu. This time we're using moles is mass over AR because it's just a copper atom on its own, not joined to anything. And that's going to be 30 divided by 63.5. Now at this point, some people would write 30 over 127 because they've seen the big 2 in front of copper. But actually AR and MR is only ever for 1 atom or 1 molecule. So when we work that out, we get 0.47 moles, which we add to the equation. And then we do the moles of oxygen, which this time is mass over MR because we've got a molecule, 2 oxygen atoms joined together. And the MR is 32. So we put that into the equation. The exam question tells us we've got 4 grams of oxygen. So it becomes 4 over 32, which is 0.125 moles. And this time we can see we need a ratio of 2 moles of copper to 1 mole of oxygen. So if we've got 0.125 moles of oxygen, really we would like 0.25 moles of copper. But in actual fact, we've got more than that. So the copper is in excess and oxygen is the limiting reactant. That's the one that would run out first and cause the reaction to stop. Have a go at question 2 for yourself and then check back in when you've tried to answer it. So this time we work out the moles of Fe first of all, doing mass over AR, which is 15 grams from the exam question, divided by 56, which is the mass number for iron, and that comes to 0.27 moles of iron. We then work out the moles of CuSO4 using mass over Mr. The Mr of CuSO4 comes to 152, and the question tells us we've got 50 grams of it. So when we put that in the equation, it works out at 0.32 moles. So we need a ratio of 1 to 1 in this case, looking at the equation. And we can see quite clearly that we've not got enough iron and we've got too much copper sulfate. So Fe is the limiting reactant and CuSO4 is in excess. Have a go at question 3. This is slightly more challenging, as you'll find out, and then once you've had a go, resume the video to check your answer. So first we work out the moles of Na, doing mass over Ar, and that comes to 20 over 23, which is 0.87 moles. We then do the moles of Cl2, which is mass over Mr, and the Mr is 71, so that in the equation becomes 50 over 71, which is 0.70 moles. Now in this one, it's quite tempting to say that the chlorine is the limiting reactant because there's less of it. There's only 0.7 moles. However, we need to look at the balancing numbers and we can see we need twice as much Na compared to Cl2. So if we've got 0.7 moles of Cl2, really we would like 1.4 moles of Na, which we haven't got. So actually the Na will run out first because we haven't got double the amount compared to chlorine. So Na is the limiting reactant and Cl2 is the reactant in excess. So just be careful of situations like that. So now you know how to calculate which reactant is the limiting reactant and which reactant is in excess. If you found the video useful, don't forget to subscribe to my channel and turn on notifications so that you don't miss any future videos. Thank you for watching.